All right, so today we're going to look at the second part of unit circle trig, which is part 2. Yesterday we focused on basically if I did not give you the coordinate, there was only 4 coordinates you knew how to find. Okay. 0, 90, 180, and 270. Those are the easiest coordinates we will work with all week. Okay. What's the coordinate for 0?
0, 1.
So 0, 1 is
0, 1, 0.
that's the coordinate for 90, up 1.
1, 0.
That's 1, 0. How about 180?
Negative 1, 0.
Negative 1, 0. And 270?
0, negative 1.
0, negative 1. Okay. So those are what we call the quadrantal angles. Today we're going to look at 3 other coordinates. Okay, so I told you unit circle trig. We're going to look at angles that are multiples of what 2 numbers? Yeah?
30 and 45.
30 and 45. And there's some overlap there, like 90. 90 is a multiple of both. But any number that's a multiple of 30 or 45. So that's what we're going to start with today. 30, the 45, and the 60. Notice those 3 points are not equally spaced. There's kind of like a gap, right? There's a gap here, and there's a gap here. Those 2 in red, we're not going to look at. Okay? Those would be the 15s. Okay? That first red one would be 15, and that red one up there would be 75. Okay? So we're only looking at the 3 that are kind of spaced out in the middle part, 30, 45, and 60. And we're going to do the same thing we did yesterday. We'll look at how do you get the coordinate, and then once you have it, how do you do the 6 trig functions. So we're going to go through, we're going to start with the 45. And we're going to go through how you get the coordinate for a 45. But after we go through it one time, it's not something we want to have to go through every time. All right? Because it takes a few minutes to figure out how to get it. So you could go through it if you forget what it is, but it's really something we just want to memorize the coordinate once we figure it out the first time, because it never changes. Okay. All right, so to figure that out, what we're going to do is we're going to draw our unit circle. And remember, in a unit circle, what do we know about a unit circle?
Radius is 1.
The radius is 1. Okay. So what I want to figure out is the coordinate for 45 degrees. Right? So the coordinate is going to tell me how far to the right I need to go, because that's the origin right there. So the coordinate's going to tell me how far right, and then it's going to tell me how far up. I don't know how far to the right I have to go, and I don't know how far up. But if you measure that, and you measure that, how are those 2 distances going to compare?
Would be the same.
Yeah, they are going to be the same. For a 45-degree angle, you go right and you go up the same amount. That's a 45. Now, to figure out the coordinate, we're going to have to draw a shape in here. So we're going to have to add a line segment to make a shape. Anybody have an idea what kind of shape we're going to make? Yes?
Like a triangle.
Yeah, we're going to make a triangle. How are we going to make a triangle?
Connect the line.
Just connect the lines. Like that?
No.
No.
So you want to draw a line from the 45 to the origin.
Yeah, so we're going to draw a line from the 45 to the origin. And now we're going to try to work with that triangle. Okay? So this angle right here is a 45. And I've drawn it a little bit bigger over there. I also labeled one other thing in that picture. I labeled the long side, which is called it's the hypotenuse. It's also it's the hypotenuse of the triangle, but this side is also the what?
Isn't it like the radius?
It's the radius of the circle. And we know the radius in a unit circle is 1. So we know that the hypotenuse in that triangle has to be a 1. Is the 1 the x value in the coordinate, the y value, or neither? Neither. No, the x and the y value, that's the x on the bottom. That's the y for the height. Those are the two values we need to find. Okay, we don't know what they are, but what do we know about them compared to each other again? They're the same, because that's an isosceles triangle. Right? Whenever you have two angles that are the same in a triangle, you have two sides that are the same. So we don't know what they are, but they're the same. So you can pick a letter. If you're used to Pythagorean theorem, you might pick like A. But don't pick two different letters, because they're not two different lengths. Okay? Whatever letter you use for the bottom, use the same letter for the height. Okay? Now, how many different letters do we have in that triangle?
2, 1.
How many different letters?
So use one letter.
Just one, yeah. If you have a problem and it only has one letter in it, then we can set up an equation and solve for that letter. We just need a formula that would connect all the sides of the triangle. Does anybody remember what formula can relate all the sides in a right triangle?
A squared plus B squared equals C squared.
Yeah, a squared plus b squared equals c squared. And what is that? The Pythagorean theorem. So let's set up the Pythagorean theorem on that triangle, and then we're going to solve for A. And A is the length of the base, which is really my x. And it's the same as the height, which is going to be the y. So once we solve for A, we're going to know the coordinate. We just have to figure A out. Okay. How would I set up my Pythagorean theorem using those three values? Yeah.
A squared plus A squared equals 1 squared.
A squared plus a squared equals 1 squared. Okay. If I have a squared plus a squared, how many a squareds is that?
2.
2. I have 2 of the a squareds. And let's simplify the right side. What's 1 to the second power? 1. We get 1. All right. What would be the next thing I could do to start to get a squared by itself?
Divided by 2.
Divide by 2. So that's gone. So we have a squared equals a half, but we want a. We don't want a squared. So how am I going to get rid of? I'm going to take the square root. Okay, I'm just going to go up over here. Okay. When you take the square root of each side, the square and the square root cancel, and you have a by itself. And to take the square root of a fraction, you do the square root of the top number, and you do the square root of the bottom number separate. Okay. What's the square root of the top number? 1. And the square root of the bottom number, does that come out nice?
No.
No. Square root of 2. So that is A. That is the length of the bottom of the triangle and the height. But what's wrong with leaving the answer for A? Right. So how do we fix that?
Multiply by the square root of
So yeah, we're just going to fix that so we don't have the square root in the bottom. And what will I end up with for A?
2. Square root of 2 over 2.
Square root of 2 over 2. That is a number you saw yesterday. We didn't know yesterday where that number came from, but that's where it comes from, the Pythagorean theorem. All right. So how long is the base of my triangle?
Square root of 2 over 2.
Square root of 2 over 2. What's the height of my triangle?
Square root of 2 over 2.
Square root of 2 over 2. So now let's translate that into a coordinate. What's the x value for the coordinate of 45 degrees?
Square root of 2 over 2.
Yep, it's how far to the right you have to go, which is the base. And what's the y value for the coordinate for 45 degrees?
Square root of 2 over 2.
It's also square root of 2 over 2. So that is how you get the coordinate for 45 degrees, and that never changes. That's always the same coordinate. Any question how we got the coordinate for 45? All right, so now, take a look at this. This is 90. That's 1/8. I'm going to show you why knowing that coordinate is going to allow you to do a 45-degree angle everywhere, okay, automatically. 45 is halfway between 90 and 0. What's halfway between 90 and 180?
135.
135. So when you draw a 45, 45, 90 in quadrant 2, it looks like this. What's the difference between the triangle on the left and the triangle on the right?
Flip.
Yeah, it's a reflection. Okay? Because it's a reflection, that means these numbers are going to be used again in that quadrant. There's only one thing that would change when you write the coordinate for 135. Yeah?
The x would be negative.
The x would become negative. Okay, I'm not going to get into that today. That's more tomorrow. But I'm just trying to show you we're going to reuse this coordinate over and over. Okay? If you make the x negative, you put it in quadrant 2. If you make the y negative, you put it in quadrant 4. If you make the x negative and the y negative, then you put it down in quadrant 3. So finding a 45-degree angle in every quadrant is all based off that coordinate. Okay, any question on that? Today we're going to stick with quadrant 1. All right? So it won't be negative today. All right, so let's see if we can do this one. Okay, find the 6 trig functions for 45 degrees. Okay, so if I want to do unit circle trig with that, what's the first thing that I need to figure out? The coordinate. Okay, they've given me the size of the angle. That's not what you need. You need to have the location. All right. So for 45 degrees, we either have to go through and figure it all out again, or we have it on a reference sheet, or we memorize what it is. Okay. So what's the coordinate for 45 degrees?
Root 2, 2, root 2, 2.
Yep, root 2 over 2 and root 2 over 2. And I think yesterday we've already done this problem. The difference yesterday is I gave you this coordinate. You didn't have to figure it out. Okay, today we had to figure it out. Right? But we can go through and just practice them again. So let's start with the sine. What's my formula for sine?
Y.
It's the y. Which number there is the y? The first one or the second one?
Square root of 2 over 2.
Which one?
Second.
The second.
Okay.
So if you switched them this time, you'd be okay because they're the same. But in general, if you switch them, you're probably going to get it wrong. Okay. So the sine is the y, which is root 2 over 2. Okay. What about my cosine?
The same.
Yep, it's the x, which is the same thing. And what about my tangent? Tangent is 1. Yep. All right. Now, once we have the 3 on the left, what do we do with them to get the 3 on the right? We flip them. Now, we did that one in the homework. Does anyone remember when you take root 2 over 2 and flip it, and you fix it, what you get for the final?
Square root of 2.
You just get square root of 2. Yep. Okay, so that means because sine and cosine are the same, cosecant and secant are the same. And what about the tangent of 45 degrees?
Same.
Yeah, because when you flip 1, you get 1. Right. And if you wanted to check one of them, you could do something like sine 45. You could type it in. The problem is the calculator is not going to give you the answer the way I'm going to ask for it. Okay? It's going to give you 0.707. But if you check your answer, type it in. Square root of 2 divided by 2. You can see that our answer is the same thing as a decimal. Okay, so we always want these as exact answers. We would never put 0.707 for that. That would be marked wrong. Okay. All right. Any question on that one? All right, so that's the 45. Now, so we did that one. Let's look at the 30 and let's look at the 60. Well, there's going to be a connection between the 30 and the 60. So we're not going to have to go through and do this kind of thing twice. Okay? Once you do it for the 30, you automatically know the 60. Right? And you'll see why. Okay, so let's start with the 30. Okay, so here's 0. Here's 90. So what I want to do is go 30 degrees. Okay? The whole quadrant is 90. 30 is like a third of it. So it's less than half. Okay, and remember, the goal is to figure out the coordinate for 30 degrees. Okay. So what shape do you think we're going to make again to do this?
Triangle.
Yep, I'm going to make a right triangle. That side that I just drew in red is going to be which letter of my coordinate? Yep, that's my x. X is the distance you travel horizontally. And the side I just did in green, that's up. That's going to be my y. That's going to be my y. So I need to figure out the lengths of those two sides. And I'm going to draw this third side in to make it a triangle. Okay. Got the same triangle, just a little bit bigger over there. Put that up there. So we know this angle right here, that's your 30. Because that's how much you tilted the hypotenuse up to point at the 30 degree mark. How do I know that that angle at the top is 60? Yeah?
Because you already have a right angle, so 90 plus 30 is 120, and the rest is 60. Because triangles are 180.
Right, the triangle has to add up to 180. So you already have 120. 120 plus what gives you 180? 60. So now you can see the 30 and the 60 degree angle are in the same triangle. That's why once you know the coordinate for 30, you're automatically going to know the one for 60. All right. So let's look at that triangle a little bit. Is there any side that I already know the length of?
Oh, hypotenuse.
Yeah, I already know the hypotenuse. How long is that?
1.
1. Okay. Now, besides being a right triangle, there's another word to describe that. What other kind of triangle is that?
Acute.
Well, no, it's a right triangle. Yeah.
I was looking at the 30.
To be acute, all the angles would have to be less than 90, like an equilateral. That would be acute. Does anybody have another guess at a word we can use to describe that triangle? Yep.
Is it scaling?
It is scaling. Okay, that complicates things a little bit. What does scaling mean?
I mean, those sides are different.
All sides are different. So if you wanted to set up Pythagorean theorem with this one, which will not work right away, but will eventually, you'd have to pick two different letters. And the problem with that is now you have a squared plus b squared equals 1 squared. When you have two letters in the Pythagorean theorem, you can't solve that. You can only have one letter. So what that means is before we use Pythagorean theorem, we have to figure out one of these other sides a different way. We have to know what it is going into the theorem. Okay, so how are we going to figure out that one of the other sides without the theorem? Well, in geometry, you learn your special right triangles. So if you have that memorized, you would know those sides already. But does anybody remember that?
No.
No. So we have to somehow come up with a way to figure that out. And I'm going to give you a hint. And that's my hint for now. Okay. So any thoughts about what I can do with that?
Make a square.
Okay. Well, we couldn't make a square, but we could definitely make a rectangle if you flip it the right way. Okay. So, yep, that's definitely a rectangle. It's got 4 90-degree angles in each corner. That makes it a rectangle. I don't know what to do with that though.
Neither do I.
Yeah. I like the idea of making something though. Yeah?
Make a bigger triangle.
Okay. How could we make a bigger triangle?
Put the 2 right angles together.
Yeah, we could put the 2 right angles together just like that. Right? Now that helps us a lot.
All sides of.
Because what do we have now if you look at the big triangle?
An equilateral.
That's an equilateral, right? This is 60, 60,
Yeah, that's what I'm saying.
60. What do we know about an equilateral triangle?
All sides are the same.
All sides are the same, which means that side is 1. The side that's going down and to the right is 1, but the most important thing, this side is 1 unit from there to there. Now, what do we know about that part in red compared to this part in blue?
They're both a half because they're the same.
Right, they have to be the same. The red part and the blue part are exactly the same. And the reason they're exactly the same is because they're mirror images of each other, right? They're copies. So you have 2 sides that add up to 1, and they're both equal in length. That should automatically tell you what the blue side is.
1/2.
It's 1/2.
Just-
Yep. The blue side has to be a half because you have 2 sides added together that are identical and they add up to 1. So each one of them is 0.5. Now we don't need the bottom triangle anymore because we've just figured out one of the other sides. Now we have 2 out of 3. We can use Pythagorean theorem. Okay. So I'm going to move the bottom triangle away so I have more room to do stuff. Let's just move that off. Get rid of all that. That. Okay, so now let's just focus on that triangle. We still don't know the bottom side, but now it's okay to call it A. And how would you set Pythagorean theorem up with those 3 things? Yep.
A squared plus 1/2 squared plus 1 squared.
A squared plus a half squared equals 1 squared. Okay, what's 1/2 squared? Half times a half. 1/4. And what's 1 squared?
That's 1.
1. Okay. What's my next step to get a squared by itself?
Minus.
Minus what? Yep, minus 1/4 from each side. What's 1? And then what do you get if you minus 1/4 from it?
3/4.
3/4. And now we're at the step we were at.
Sorry, I just make noises.
We're at this step right here. We have something squared equals a number. So what do I do to get rid of that exponent of 2? Take the square root. Square root. When you square root something that's squared, that goes away. And how do we take the square root of a fraction?
Put it on the bottom.
Do what?
Put it on the bottom.
No,
No?
No.
no, you square root the top and square root.
Square root both parts.
You
Yeah.
just
Oh,
like figure it out.
When you square root the top, do you get a nice number?
No.
No, and that doesn't matter because it's in the top. But when you square root the bottom, do you get a nice number?
Yes, you get 2.
Then that's good because now the bottom is already a nice number, so we don't have to worry about fixing it. Okay, so now we know the bottom side is root 3/2. Okay, so let's label that in our picture. How long is this bottom side?
Oh my God,
Root 3/2.
Root 3/2. Okay. How tall is the triangle?
1/2.
A half.
1/2. The bottom side is which letter in the coordinate?
X.
It's the x. That's root 3/2. And the height is what other letter?
Y.
That's the y. Yep. So that is always the coordinate for 30 degrees. Root 3/2, comma,
So for
1/2.
60, you just flip it.
All right, so now let's look at the 60. Okay, draw the triangle for the 60. know it's a little bit, because now we get two triangles, but that's the 60.
That's the same triangle.
It's the same triangle. So if I like trace it out, this triangle in blue and this triangle in red, they are the same triangle. The only difference is the red one is standing up on the short side, where the blue one is kind of laying on the long side. So what do you think that means the coordinate is going to be?
1/2.
Right. This
Square root 3/2.
this part of the triangle is 1/2, because that's the short side, and this is the long side. That's square root 3/2. So the way you can remember which one is which is when you draw a 30, 60, 90, there's always a short side and there's always a long side. The short side is always the 1/2. The long side is root 3/2. Right? And that's because if you look at the decimal, 1/2 is 0.5. Root 3/2 is 0.866. Root 3/2 is a bigger number than 1/2. So root 3/2 is always the long side, and 1/2 is the short side. So as long as you draw your diagram somewhat accurately, you should see a short and a long side. And just remember, the short side is always the 0.5. All right? So now we've got the 30, and we've got the 60. So we've got those two. But if you have those three, you really have those three, and those three. You have all of them. Because the only difference between the coordinates in these other quadrants is either the x is a negative, the y is a negative, or both the x and the y are negative. Okay. So those are the three coordinates you have to remember. 1/2, comma, root 3/2, root 3/2, comma, 1/2, and root 2/2, comma, root 2/2. Those are the only, and even tomorrow, we're not going to be learning any other new coordinates besides those. They're just going to have negatives in front of them. Okay. So any questions on how we got the coordinate for 30
No.
or 60?
No.
It does require to be a little bit clever, to make like a copy of that triangle and just try to figure it out that way. That's one way you can do it. All right, so let's try this one. Find the 6 trig functions of pi divided by 6. Okay, what have they given me in that problem? Which is what? Like, what does pi over 6 represent? They've given me the size of an angle. Not helpful. Not directly. What is it that I really need to do unit circle trig? I need the coordinate. I don't need the size. I need the location. So I have to figure out the location for pi over 6. What might be my first step to help me eventually get the location for that? Yep.
Convert it to degrees.
Yeah, you can convert it to degrees if that helps you. Is it necessary? Not if you're familiar enough with radians. You got to get the coordinates somehow. If that helps you, then go ahead and do it. So multiply by 180 over pi. Pi's canceled. And you're left with 180 divided by 6. That is 30. So I want to get the 6 trig functions for 30 degrees. So is the 30-degree problem the one where the x and the y are the same coordinate, or they're different?
Different.
They're different. So it's the one with the 1/2 and the root 3/2. If you forget the order, which is important, draw your triangle. Put 30 in a roughly accurate spot. Okay, so it's less than a half. When you make your triangle, it should be pretty obvious that there's a long side and a short side. The long side is always which number? Well, no, a number. In this case, the long side is x, but the x is what value?
Square root 3/2.
Right, the long side is always square root 3/2. And how much is the short side? 1/2. So now we know our coordinate is the horizontal, comma, and then the vertical. Horizontal, 3 over 2, and the vertical, 1/2. Both positive because we are in quadrant 1. All right, now we'll go through our 6 trig functions. All right, let's start with the sine. What's going to be the sine of pi divided by 6? Yep, it's the y value, which is 1/2. Okay. What about the cosine of pi over 6?
Square root 3 over 2.
Yep, square root 3 over 2. The tangent of pi over 6, what's the formula for that? Y over x. So just imagine you have y and x right above you. So visually, just imagine putting a division line right there. When you divide those fractions, what happens?
Twos go away.
The 2's go away. What's left in the top?
One.
No, one's left in the top. And what's left in the bottom? The root 3. And when we fix that, so we don't have a square root in the bottom, what would be our final answer for tangent?
Root 3 over 3.
Root 3 over 3. Yep. Okay. How about my cosecant? Yeah, take the sign and flip it. Okay, it's going to be 2. How about my secant? The final answer, no square root in the bottom. 2 root 3 over 3. Yep. And for cotangent, you have 2 different numbers you could flip. The final answer, or what we started with before the final answer. Which one would make sense, or which one would be faster to flip? Right, the first one. Because what happens when you flip that? It just becomes root 3. The root 3 goes to the top and you're done. If you flip the final answer, that's okay. But now you just put the root back in the bottom and you got to fix it all over. Okay, so just flip the first one, root 3. And that's the 6 trig functions of 30 degrees. Any question on that one? So now, I want you to try the 6 trig functions of 60. And then I put them both on the board because then I want to compare. We know the coordinates are pretty similar, so all the answers should be pretty similar. We're gonna see what happens with the answers.
So you flip everything.
Well, yeah, there's going to be a lot of things that kind of change places here, but it's going to be a question of what changes places with what. Okay, but yes, you are going to see all the same answers again over here, but they're all going to move around. Okay, so let's see how they move around. Okay. So last question they want us to do is find the 6 trig functions of 60. Okay. What's the first thing that we need to do to be able to do all 6 of those? Yep.
Find the coordinate.
Right, we have to find the coordinate. Okay, we just did the 30, and we know the connection between the 30 and the 60. So what's the coordinate for 60? 1/2 root 3 over 2. Yep. Let's go through our values. What's going to be the sine of 60 degrees? Yep.
Root 3 over 2?
It's going to be root 3 over 2. How about the cosine of 60 degrees?
1/2.
That's going to be 1/2. And the tangent, just imagine putting a division line right there. What do you get when you divide the y by the x? Yeah?
Root.
Yeah, the 2's cancel, and all you're left with is a root 3. All right, how about my cosecant?
2 root 3 over 3.
Yep, when you flip that, it's 2 root 3 over 3. How about when you flip the cosine to get the secant? You just get 2. And how about when you flip the tangent to get the cotangent?
Root 3 over 3.
Root 3 over 3. Okay, so now I want to look at which answers switched places. Can somebody name a pair of trig functions where the answers switched places. Yep.
The cosine was
The cosine and the, which one?
cosine was. The sine and the cosine.
Right, the sine and the cosine switched. Over here, we had a root 3 over 2 and a 1/2. Over here, we had a 1/2 and a root 3 over 2. So these two switched. All right, what other two switched? Yeah,
Tangent and cotangent?
right, these two switched. We had root 3 and then root 3 over 3. Over here, the root 3 over 3 was on the left and the root 3 is on the right. So those two switched. And then the last two that switched were the cosecant and the secant. And if you pronounce the trig functions that switched, you'll kind of notice a pattern. Sine, cosine, secant, cosecant, tangent, cotangent. So the ones that switched is the ones when you put a co in front of the name. Those are called co-functions. Okay? Tangent and cotangent are special because you can flip one to get the other, and they are also co-functions. The other ones are not. You don't flip sine to get cosine. It doesn't work that way. They are co-functions, but sine and cosecant are the ones you flip to get each other. So that part's a little different. All right. So any questions on finding the 6 trig functions of 30 or 60? Okay. So if you look at the homework for tonight online, it's a worksheet. And each question on the worksheet has 2 parts to it. Okay. Let's just make one up and do it. If that was a question on the worksheet, first thing I'll do is I write down a spot for the coordinate, and then I write down a spot for the answer. So the coordinate is the location. What's the coordinate for 45 degrees? Yeah?
Root 2
Root 2 over 2, root 2 over 2. Now, the cosine is the actual answer, so you need to know what to do with the x and the y. The formula for cosine is which letter? Is the x. So the answer to this problem is root 2 over 2. And that's how the questions on the test are set up. 2 parts, coordinate on one part, answer on the other part. Right. So there's 10 problems on the worksheet. So you'll do those 10, coordinate and answer. And then same thing here. I just added 5 more, and there could be some review questions in there from yesterday as well. So there's 15 total questions. Anybody unsure where to find that worksheet online? It's in the 2.2 Part 2 homework folder. So there's no PDF in that folder from the book tonight. There's a worksheet.